Can you now analyze whether my to-do app is compliant? AI readiness score, that looks great. Thank God. Portal onboarding is complete. That is fantastic. Policy violation detected. Alarm. Database resource violation. Policy cost optimization RDS sizing. Resource to do a production DB. Violation type overutilized. So our recommended configuration is an instant type for DBT3 micro, vCPU 1 GB. That would bring us down to $16 and we would save $830. Fantastic. Automated remediation available. Hey everybody, this is Kaspar and welcome to a new episode of Building Platforms with Kaspar. Today we're going to build a super exciting one. We're going to use Cortex, we're going to use VMs, we are going to use Humanitec, we're going to use Claude Code, all of your favorite tools. And we are going to actually cover two paths. And today we're going to take more the perspective of the platform engineer. Path number one, we're going to detect a policy violation using Cortex amazing scorecard functionality. And then we're going to remediate this. We're going to see that there's an overprovisioned Postgres database and the platform team will enforce a downgrade into a smaller version without actually involving the developers. Very exciting path number one. And number two, we're going to show you how to add the capability of allowing developers to request S buckets to your platform. That is something that we are going to craft essentially as platform engineers, create a golden path that is reusable for our developers. If you have questions, leave them in the comments below. And now let's get started. Happy platforming. And we're going to start, as always, with a review of the architecture. Here is our architecture. And you can see that we have the control layer on top. We have the backend integration plane. We have the resource plane. Let's start with the interfaces. If you've been following me, you know that I believe in interface choice. The developer, the user, whoever is interacting with your platform should choose the interface that works best for their individual workflow. And that could be an IDE extension, it could be the CLI, it could be the API, it could be Claude Code. It could be the user interface. And so we are going to look at all of those different things. We're going to look at the CLI. We're going to look at pair programming assistance. We're going to actually use the new Cortex MCP server, which is super powerful. We're going to use the Cortex portal. All of those are things that we're going to explore today. The interface choice is only possible if you have a consolidated backend. Everything is code. Everything is an API. And so we will store and talk a lot about repository design. We are going to see that there is an application source code repository and a platform source code repository. We are going to introduce those separations of concern to drive standardization. And then we have the back end that is executing all of this. We have the CI pipeline, the registry, the orchestration of the logic handling component in the back end. And we're going to deploy into an AWS account. The compute that we are using today is for now, and this is like a premiere because I've done so much Kubernetes stuff. Today it's going to be VMs with EC2. We're going to use Postgres with RDS. We're going to use S3 for object storage and a couple other technologies. Monitoring and logging is going to be done with DataDog. Not so much of a focus today. I'm going to focus on that in one of the next videos. And for the security plan, we're going to use a secrets management tool with HashiCorp Vault. Let's explore this platform now from the infrastructure up, and let's start by looking how everything is wired and orchestrated. So to configure the infrastructure, we're using Humanitec's platform orchestrator, and this is the graph, the resource graph, essentially, that shows us what is already running. So we see we have a workload called the Fresh To-Do app, great name, and we can see that it's running on a VM fleet and that we have a Postgres database. Okay, so first we have to answer the question, where is this running and why is this and how is this configured and how is this all wired up? And so we will start at actually looking at the repository structure of all of this to get an idea. And now let's actually have a look at the repository for the to-do application. We can see we have a structured standard code here to configure for the actual source code. And then we have a Docker file, this is a containerized application. And we have our GitHub workflows that really just build the image and then push the changes to the orchestration to then pick up, etc. Now, more interesting than what we see is what we do not see, and that is the infrastructure configuration. So we're choosing a pattern here that separates the application configurations and the infrastructure configuration, separation of concern to drive standardization in our platform. Now, that means that the developers are more focused on the application development side, and the infrastructure, cloud ops, platform engineers are focused on setting the structured standards of the infrastructure. Okay, so we are going to look at that in just a second, but somehow the developers need to articulate what they need for their workload, right? And you want that to also be stored in code for disaster recoverability, tracing, etc. And so for that, we have one file here that's called the manifest YAML that describes what this workload actually needs to run. So what do we have here? We have a compute of type VM fleet, right? That means we need virtual machines so that workload can run somewhere. And then we need a database of type Postgres. Okay, and then we have our workload, the fresh to-do app, and this workload has environment variables. We have the database URL, host, port, name, user, password, and we have a load balancer URL. Okay, and so what this now actually allows us to do as developers, and we're going to go through a couple of golden paths on that later, is to just express what we need. If we would want to have other infrastructure, we could literally just articulate that here in abstract terms, and you can see that this is environment agnostic. These things can be pushed against dev, environment, and staging, and they'll be automatically resolved. And that gives us this very good amount of structure. So this is the part of the application developers. Let's look at this here again, just from the theoretical concept. I said that in the last video that this is so important, how you think about repository structure in platform engineering. We just look at the application source code with our workload source code, with a manifest file that I just showed you, with the application configurations, with a pipeline YAML. So this is really the bit that is usually taken care of by the application developers. And then on the other hand, we have the platform source code. Those are the modules. Again, you probably want to use infrastructure as code. We will be using Terraform in this example. And you then also have your providers and configurations of the backend. Again, all of that should be stored as code. We'll have a look at that in just a second. Now, logically, how do these things come together? Now, how does that actually now come together? How do we resolve the abstract request from the developers against the rules provided by the platform team? Well, we do that with an orchestrator. Pretty straightforward. The developer articulates what they need. I need a workload, and with VMs and Postgres, what I just showed you, that flows through the CI pipeline, and then the orchestrator figures out, is this going to dev staging, production, ephemeral environment? So what's the context? Depending on the context, it's fetching the rules by looking up what the platform engineering team has configured, and then it is executing those infrastructure as code components, making sure everything runs, puts it together, and then wires everything up and serves it back to the user. And then the developer can start coding right away. Okay, so with that in mind, let's look at the infrastructure repositories. So here we can see the infrastructure repository, and I've kept it super simple. We're really now starting with that VM layer and then with the Postgres. And I have actually two Postgres versions here, a Postgres standard version and an overprovisioned version. You'll see why I'm doing this in just a second. And I'll walk you through how to add more modules here and wire them up and set the rules. But what we're seeing here are really just plain Terraform files. We can see our main TF outputs variables. That should look very, very familiar to you. Now, on the other hand, we have the rules that allow us to tell the orchestrator when to use what module and in what way. And how the orchestrator is configured is something that we can see in a dedicated repository here. Again, like, I'm a big fan of keeping all of the different configurations as code, and you can see that we are calibrating or configuring what module to use in what situation and in what context. Let's actually, to make this a little easier to digest, navigate to the user interface of the orchestrator here. And concretely, we go to the modules, and you can see that here on the VM side, it's actually telling us to use the repository that I just showed you if somebody needs a VM. And to do that, if the following rules are hit, use this in any case. Okay, so this is a very, very simple rule, but we could also apply rules that are depending on environments, depending on IDs, etc. So this is how everything. So just to recap, we have the application source code repository that just references what I need or what the developer needs in abstract terms. And on the other hand, we have the platform source code with the models, with the providers, and with the configurations of the orchestrator. And this way, if we just deploy something, if we just scaffold something, however we want to do this, and the CI pipeline can run, the orchestrator can run. And that way, if we now deploy something, we can just scaffold somewhere here on the interface side, depending on what interface I want to use as a developer. And this will fly through the CI pipeline. Actions will pick this up, push this to the orchestrator, manifest file will be read. We'll figure out what Terraform to use or what other infrastructure as code you would want to apply here. And then we can generate the resource plane. Yeah, and that actually means, we can now go to the Amazon console and I can show you the EC2 instance, the RDS instance, etc. I'll do that later, and you'll just have to take my word for now. There's one more thing that we've configured here that I find interesting. We have configured the orchestrator to use the ECS Runner. So we're using ECS as the runner, to use ECS as the runner. What does that mean? Well, the runner is the thing that receives the deployment request from Humanitec and then spins up a Fargate task with your Terraform modules to then actually do the execution on your cloud account or on-prem or wherever you'd want to do this. Well, in this case, it's our Amazon account. And this is then the thing that will provision the EC2 instances as virtual machines and deploy our application into them. There are two ways to configure the ECS runner. Number one, you can actually let the orchestrator launch the runner remotely, so to speak. You would need to give it access for it to actually start that job. Or alternatively, you can set this up in a way where you run an agent on your infrastructure. That agent polls for events. And then if there is a runner development, it can actually pull this in and then run everything in an air-gapped environment. And that is great from a security perspective if you have specific requirements there. So let's just recap once more what happens if I'm actually scaffolding something. I'm starting from scratch. Well, first of all, we would start this somewhere. So we would scaffold the repository, would click a button in Cortex, and we'll review all of the portal layer in a lot more detail in just a second. And then we will scaffold some application source code. We would kick off a CI pipeline. The CI pipeline would actually start building, call the orchestration. The orchestration would read the manifest file, create a dependency graph. It would then start with provisioning the VMs first. So those are EC2 instances behind a load balancer. It would then provision the Postgres, make sure that has proper security groups to allow the VMs to access that database. And then it would inject all of the different connection details as environment variables. Once this is done, GitHub Actions will continue. It will pull the image. It will, again, inject the database credentials securely as environment variables again. Then it would do health checks and load balancer routing. And it then handles the rollout and the scaling, and then our application is running. And then the developer would take the repository that's scaffolded, git clone, and would be able to develop locally, has their development stage in production environment, however, that startup scaffolding script is configured and is ready to go. Okay, so all of these things are things that I've done for you already, so you don't have to wait for expensive VM and large Postgres databases to start up. Okay, so now I want to deep dive on the portal layer. Cortex was friendly enough to give us an amazing instance here with a couple of things already configured with our own setup. And so I want to explore that. And then I actually want to walk through some golden paths. So here we are in Cortex. Cortex is our portal. That means it's the front end on top of our platform, visualizing all of the things that we have, our repositories, our infrastructure. It's really our single pane of glass. Now, if we go into the home screen, That's really nicely configurable here. We have everything on my, PR and Git level here at a glance. We can access the catalog to actually search for stuff. I'm going to show you the entities in just a second. We have teams, we have services, we have infrastructure components. Then we have something that Cortex is really famous for, and that is the scorecard system. That's something that I'm super excited about. And they've just released a new set of scorecards that is focused on AI readiness, something that's so important at the moment. So we have 3 scorecards here as an example. We have a compliance check that will play a role later. We have AI readiness scorecard, and we have an onboarding scorecard. So you can see this is a portal, like the onboarding to a portal never ends, but this is a portal that is actually currently being set up. And so this onboarding scorecard is super helpful. I can wire these things up to initiatives to actually drive things, like in this case, something that lots of you do at the moment. Everybody does this, prepare to roll out an AI assistant. And that's something that you can really nicely oversee here using Cortex. And then we have workflow runs. Workflow runs are essentially starting points for golden paths. If I want to give the developers the opportunity and the option to actually start things, request things, change things, get access to things from my portal, I would configure that as workflows. Okay, so this is my home screen here at a glance. Let's look into the catalog. The catalog is really the thing that allows us to see what's going on and look at all entities here. You can configure so many different entities. It's a very, very powerful entity structure that allows you to model to exactly the data structure your organization follows. I have 2 entities enabled here. For one, my engineering team, and then I have my services. So if I go into a service, I see everything on that service again here at a glance. I can see whether this is part of ongoing initiatives. I can see scorecard usage here. Is this compliant? And we can clearly see it's non-compliant. AI readiness, onboarding. I can see my latest events. I can see whatever else I wire up. That could be observability, this could be health checks, this could be incident reports, really here immediately for me to see and consume. Now, then, beside the catalog, we have the beautiful feature of scorecards. And again, scorecards, we have 3 configured here, are this way of helping us assess how we are scoring in terms of how entities meet policies. Now, if we go into this onboarding scorecard, for instance, we can see how my different repositories actually hit the rules and what level we currently have. So we can see that 174 are not there yet. Bronze is a 58, silver 0, and then gold 0. So we still have a little bit of way to go, and we can see what the rules are actually assessed against. This is a pretty qualitative, beautiful thing here. So in order to meet bronze, we need to have a GitHub repository. It needs to have a README file. It needs to have owners. It needs to have a description. For silver, it needs to have at least a link of a type of documentation. It needs to have a runbook, dashboard. And for gold, we need to say, and we need to have on-call rotation set up, and it has to have SLOs. Okay, so this is just a simple example. Let's take another example here, AI readiness, also super powerful. Again, let's look at the rules. So we have for bronze version, control in use, basic documentation, service ownership defined, basic health monitoring, dependency management. For silver, we need to have secrets management in, automated CI/CD pipelines, test coverage minimum, integration test implemented, SLO defined, incident response runbook, deployment rollback capabilities. And for gold, we need distributed tracing, change approval process, data classification documented, comprehensive audit log, 0 critical and high vulnerabilities, AI model security scanning, and feature flex for controlled rollouts. And then we have that system, and Cortex will now change in a frequency that of our choosing how our different repositories actually work or compete against those scorecards. They're super simple to set up, yet super powerful. They have their own domain-specific language that allows us to really calibrate and configure precisely how we want entities to meet or not meet our policy requirements. So scorecards, really one of the things that, Cortex is known for, and that is indeed very, very powerful. Now, we can aggregate those scorecards and everything that's going on into reports. So we have the executive report, for instance, and that report will give us really everything at a glance here. What needs our attention? How are we doing? What's our change in terms of how we're meeting the policy over certain periods? How often are we deploying all of those things? Again, highly configurable. So many different types of reports you can build. And then lastly, I'm going to show you the workflows. These things that allow us to just start activities and actions from right here from our portal. It's so nice to build these workflows. They have all of those templates that you can use, and you can also just start from scratch. And we call this the sample workload, and it will allow us to build these things visually. And that's very, very nice and convenient. We can make HTTP requests. We can, ask for user input. We can do validations, etc. Very neat, very well crafted. Another thing that I found super exciting when testing Cortex is the new MCP server. That's something that they've just recently released, and it allows you to really natively and with natural language interact with their systems and API. And let's actually do this and ask a couple questions. So for instance, can you analyze the performance of my engineering teams? And let's see what they get us. And let's see what the output is here. Engineering team performance analysis, 10 total teams. Analysis period lasts 30 days with sources from GitHub, Jira, Cortex, scorecards, deployment pipelines. So we see the top performing teams here. We see the deployment frequency, service reliability, mobile engineering. You see a breakup of all of the different teams, velocity, recommended actions. That's crazy. It's so insane, right? And I've really tried to see, does that hold up to reality? And it's surprisingly precise, actually. Let's try another one. Can you now analyze my AWS estate? And let's make this a little larger so you can see better. All right, we have a result. Let's check. Here we go. Global infrastructure overview, account ID, my monthly spend, distribution, utilization, ECS analysis, service distribution, cost breakdown, optimization opportunities, overprovision services, underutilized regions. I mean, this is just mind-blowing that you can get all of that information from an MCP server here. Yeah? So that's super powerful. And that's the power of an end-to-end connected internal developer platform here, including recommended actions and everything. Cool. Now, let's actually go back to our example that we were working on. Can you now analyze whether my to-do app is compliant? Let's see whether there is anything. And here we go. Let's check that. Cortex scorecard analysis to-do app service. Retrieved service overview. To-do app. We are the owners. Compliance status. AI readiness score. That looks great. Thank God. Portal onboarding is complete. That is fantastic. Policy violation detected. Alarm. Database resource violation. Policy cost optimization. RDS sizing. Resource to do a production DB, violation type overutilized. Current configuration DB3 G2X large, my God, with 8 vCPUs and 64 gigabytes of memory here with $847 cost every month. And we're not utilizing this. So our recommended configuration is an instant type for DBT3 micro, vCPUs 1 gigabyte. That would bring us down to $16 and we would save $830. Fantastic. Automated remediation available. Cortex workflow, database right sizing, workflow ID, execution step. Okay, recommendation, execute Cortex workflow to resolve the database sizing violation and achieve immediate cost saving. Okay, Okay, so it's not only showing us where we're compliant and where we're not compliant, it's also calculating the costs, and now it's telling us what to do to actually remediate that policy violation. And this is where the first golden path comes into play. What is a golden path? Well, the golden path gives us capabilities and an interface. So this is our interface here, capabilities to actually respond to situations in a way that we can trust that we are actually able to resolve this. In this case, we have the violation of an over-provisioned database. Now let's actually see how we can use our platform to help our engineering teams downsize this. And in this demo here, I want to show golden paths for platform engineers, right? So in other videos, I showed golden paths for developers, etc. Now I want to show how you, as a platform engineer in this situation, you're seeing that this is a wildly over-provisioned setup here, can go in and you can force upgrade the system to actually have a less costly variant, but still making sure these things run. How do we do this? We could now just start this workflow here from the MCP server. Let's go back to the Cortex UI to show you how this is done. All right, here's the UI of Cortex, and we go to workflows, and we go right size RDS workflow. That sounds perfectly fitting. Run workflow, and now we can just specify the service name on which we want to perform this upgrade. And usually I would have validation. Can I check from my repositories, and I am going to downgrade to dbt3 micro, and then I will only apply this to dev because I want to see whether that works before I actually enforce this everywhere. And with that information, Cortex has now made the HTTP request to call the orchestrator to actually perform that execution. And now what actually happened is that the Cortex workflow made a call to GitHub and created a pull request. And that pull request is now changing the rules on how the orchestrator is configured. And it says for the fresh to-do app, we don't want to use the large Postgres, which is over-provisioned. We want to use the standard Postgres because that will save us up to 60% cost. That pull request is done here on the Terraform of the Humanitec configuration. And then the Cortex workflow will enforce a deployment on the development environment only. So let's have a look at that. So you can see that the rules changed. What didn't change is the manifest. So this is the developer part of the equation. It's still asking for a compute with VM, and it's asking for a database of type Postgres. And that stays the same. Just under the hood, Cortex is now enforcing a change by calling the Humanitec orchestrator. The Humanitec orchestrator switches to the smaller version and is now orchestrating that infrastructure. It's downsizing, it's eliminating the over-provisioned instance, and it is spinning up the larger one. We only do this in dev. We will usually do this at scale with progressive rollouts and testing before we progress here. But you can see that we can do this under the hood without actually involving the developer, and that is super, super powerful. All right, let's have a look again here. What happened? We asked the MCP server, is there anything that is out of policy? The server says, yeah, there is something. We are using a database that's too large. And then we go to Cortex. We start a workflow. The workflow will then change the code-backed configurations for the Humanitec orchestrator. It will then run a deployment. The pipeline is running. The orchestrator will swap from the larger over-provisioned Postgres database to the smaller one without the developers actually even being bothered. And then the resource plane will update and everybody's happy. Here's our golden path. Fantastic. Next, we want to do or show a golden path where how platform engineers can actually add capabilities to the platform. So, for instance, resource types, so developers can request them. Because if we don't have that and developers request something, that's a frustrating experience. Actually, before I show you how to teach the platform how to support new resource types, let's see what happens if the developer wants to do something and the platform blocks them from doing so, right? I want to use the example of the developer wants to add an S3 bucket to their existing workload that's running already. And how they would do that is that they would go to their manifest file. Let me open that, make this a little larger for you, which says I need a VM fleet and database, and my workload has certain variables. And now I go ahead, and all they would need to do, in theory, is give me a bucket of type S3, and then they would deploy this. And when I'm done, I can just git commit this and see what happens and kick off the workflow. Okay, and so here we actually have that deployment, and we can see that it is failing. So this is doing all the things it should do, and then when it's supposed to deploy to Humanitec, is failing. And why is it failing? It's failing because the platform doesn't know how to create an S3 bucket yet. That's something that we haven't configured. So that's the next thing we need to do. We need to teach this system how to actually configure or how to actually create and generate an S3 bucket. In order to do that, we need to do two things. We need to add a module, right? An S3 module with Terraform, for instance, and then we need to add rules. Let's do that now. All right, and now we have here an S3 module. We literally just took the one from the Hashi registry, and all we have to do is now cd into the in our Humanitec Terraform module repository, and then we run git add s3, and we run git commit, and boom, here we go. And once we're done with this, we git push. All right, perfect. And now that means we have our S3 module added to that repository. And then I go to the module rules TF. So this is where I actually have the rules for Humanitec as code. And I add this bit here. So that means I want to add an S3 bucket here. Resource class is default. And I'm going to use this only for dev environments. And then I git commit, and we say add test capability for dev self-service. And there's a little mistake here. This is already pushed. Okay, everything's up to date. Okay, so we added the module, the Terraform module. We configured the module in Humanitec, and we added the rules when that module should be used. Now we also need to add the resource type. The resource type is allowing the engineer or the developer to say, give me a resource of type S3. So we need to, Humanitec needs to know that it's now supporting the type S3 as a resource type. And I've already done this for you. So here you can see S3 resource types, which will give us AWS S3 object storage buckets. Okay, so that's done. Fantastic. And that means we can now enforce a deployment. So we'll do this. And to speed this up, I've done this for you 5 minutes ago. And here we go. The to-do app is deployed. Everything is running. We now have an S3 bucket, which should show if we look at the resource graph. Let's see whether I can get that up. And yes, here we are. So we have the fresh to-do app. We have the VM fleet, we have the Postgres, which should now be a small one. Yeah, so this is the small one. The small one was called Fresh Postgres Standard. The other one was called Oversized. And we have the S3 bucket from our second path here. That is our S3 storage, deployment ID, environment ID. We can use this to look up in the AWS console what the actual resource is. A project ID, resource class default, resource ID is shared bucket, and resource type S3. So what have we done in this path? The developer deployed and then figured out, I don't have the ability to deploy S3 or to get S3. And then as platform engineers, we have added the module with Terraform. We've set the module rules in the orchestrator. We've added the resource type S3 to enable developers to reference that. And then we've forced a deployment again. And if you recall, the developer had already added the S3 reference in the manifest. The deployment went through. The S3 bucket was created, added. We have it in the resource graph. Everybody's happy. And that means our little episode today comes to an end. We've looked at this architecture with Cortex and AWS and all of the different components, and we've done two paths. Number one, we've detected a policy violation, an oversized, overprovisioned Postgres database RDS with AWS, and then we showed the golden path for the platform engineer to actually downsize this as a fleet, in this case, for our to-do app. And second, we showed how to actually add new capabilities, new promises, new golden paths for our developers by adding resources of type S3 and giving our developers the superpower to just request them for their workloads super fast. I'm recording more of these videos. There's a really interesting one coming up with a friend of mine over at Nagaro, Sasha, who's showing us the setup that he has built. So we're recording this week, and there are a lot very, very cool ones coming up around high security cases, defense cases, banking cases. So stay tuned. Follow us on the socials. Leave a like, leave a comment. Public. And we're also going to publish the source code of everything that we've done here soon, so you can replicate this setup at home. If you have questions, let me know. Until then, all the best. Happy platforming.